In this video, I'll cover a number of space startups working on power beaming satellites in orbit. These companies plan to beam power to other satellites or down to Earth and even down to lunar rovers. If you think about it, all of these startups are fixing one issue: shadows. Earth's for most, other moons for lunar operations. Solar panels generate no electricity when blocked from the sun. The orbital economy is worth $600 billion and could approach $1 trillion by 2040. More and more of Earth's surfaces rely on orbiting satellites, from Earth observation, communications, to internet, and soon AI compute will all be carried out in space. A typical satellite in orbit around Earth spends 1/3 of its time in shadow, needing to rely on battery power to survive. Operations either stop completely or are severely degraded during this time. To mitigate this problem, satellite operators can put their satellites in sun-synchronous orbits to minimize loss of sunlight, but that leaves them outside of their mission area 70% of the time typically. The better solution would be to provide continuous power no matter the orbit, and that's exactly what these power beaming startups aim to do. First, we'll start with a brand new startup that just came out of stealth mode, and then cover their competitors, which I've covered extensively on this channel already. I'll finish with my thoughts and the future plans for these companies. Hey everyone, quick thing before we dive in. Join my weekly live stream this Saturday. I recap all my videos this week, including slides, images, and extra clips you might have missed. At the end of each recap, I read out the best comments left for that video and answer chat messages. Ask me anything on any space topic, or just chat among yourselves about the latest space events this week. The more people chatting, the more fun it gets, and yeah, super chats definitely get priority. So drop your comment right after watching the video, and I'll see you this weekend for the full recap and live Q&A. Find the live stream link in the pinned comment for this video. Okay, let's cover a brand new space startup planning to beam power from space. Mantis Space just emerged from stealth with more than $10 million in seed funding. Their tagline is powering the space economy. Mantis calls themselves a power utility company for space missions. They plan to build a constellation of spacecraft orbiting the Earth, capturing solar energy and transmitting that energy to other spacecraft. It's the start of a power grid in space. Lack of power in space is a major bottleneck for satellite operators. As more satellites launch, the need for space power will only increase. Mantis plans to provide power to a wide range of spacecraft, from communication and Earth observation satellites to scientific missions and orbital data centers, space stations, and even lunar operations. Mantis's power satellites will be stationed in medium Earth orbit and can beam power over distances thousands of kilometers. Okay, on to our next power beaming startup. Starcatcher, a company I've covered on this channel already, has the same plans as Mantis Space. They're building the Starcatcher network to collect and store solar energy and beam it to client satellites in orbit. They plan to build the first space-based energy grid, although they now have competition with Mantis Space for that mantle. No retrofit of client satellites are needed, as a Starcatcher satellite will beam energy in a range suitable to be captured by solar panels. Power from 100 watts up to 100 kilowatts at flux concentrations of 0.1 suns to 10 suns are available. Typical solar panels generate around 250 to 400 watts of energy, so Starcatcher can easily compensate for loss of power due to a satellite entering the Earth's shadow. Starcatcher carried out a ground demo in March 2025, beaming power over 100 meters to multiple off-the-shelf solar arrays. Further ground tests in the summer of 2025 extended the power beaming range to over 1 kilometer. The company broke the world record for wireless optical power beaming in November 2025, sending 1.1 kilowatts of power over a 1 kilometer distance at NASA's Kennedy Space Center. They have a partnership with Intuitive Machines for a lunar demo, beaming power to their Moonracer rover vehicle. An on-orbit power beaming demo is scheduled for 2026. This will be a subscale demonstrator with commercial operations starting in 2027. Okay, on to the next startup. Overview Energy plans to beam solar energy from space down to Earth. The company is specifically targeting solar farm operators. as these assets only provide revenue when the sun is up and shining. If energy can be focused onto the panels at night or during adverse weather, the solar farms can produce continuous power. Overview plans to beam down infrared energy, which existing solar panels can convert into power directly. Other space-based solar power concepts require a dedicated receiver antenna, or rectenna, that adds costs and complexity. Overview avoids that by focusing on existing Earth infrastructure such as solar projects. The company plans a constellation of satellites to provide reliable power, switching the beam to different clients as the satellites move in orbit. Because existing solar projects can be used as Overview's receivers, there's no new land, no new construction, and no years-long wait for interconnection. Just sign a contract and receive additional energy directly onto the solar panels when Overview satellites pass overhead. Okay, onto a startup that's working on beaming massive amounts of power down to Earth. Space Solar, a UK space startup, is working on commercial-scale space-based solar power to provide clean and affordable energy from space. The system captures sunlight in space where solar energy is abundant and uninterrupted. Positioned between Earth's shadow, their solar arrays collect energy 24 hours a day, 7 days a week, unaffected by weather, seasons, or time of day. The captured energy is converted into radio waves and safely beamed to Earth. A mesh network of ground-based antennas collects those waves and converts them into electricity to be supplied to a national power grid. To be cost-effective, the power satellites are large, ranging from 400 meters to 1.7 kilometers in diameter. The satellites are assembled from thousands of small, mass-produced modules. These modules are manufactured on production lines to keep costs low and transported into orbit using reusable rockets, such as SpaceX's Starship. In space, small autonomous robots assemble the modules into fully operational satellites. Once complete, the satellites begin beaming power to Earth, while the robots move on to build the next satellite. Independent studies confirm that SBSP is technically viable and economically competitive with other renewables. The system is dispatchable, which means the power output can be adjusted to complement varying power sources like wind and terrestrial solar. Space-based solar power is a reliable, constant source of energy that helps stabilize the electricity grid. In addition, the beam point can be relocated for other needs, such as supporting green hydrogen production, water desalination, or remote operating bases after a natural disaster, for instance. Space Solar has exclusive rights to the Cassiopeia solar power satellite design. This solid-state design eliminates the need for mechanical systems, which are prone to failure at the scale required for space-based solar power. Each solar power satellite features adjustable reflectors that dynamically tilt to track the sun, ensuring sunlight always shines on the fixed solar panels. The satellites weigh between 80 to 600 tons, converting collected solar energy into microwaves for transmission to Earth. On Earth, the ground station antenna, spanning 1 to 4 kilometers in diameter, receives the incoming microwave energy, converting it into 50 to 600 megawatts of continuous electricity. By 2030, Space Solar aims to launch Merlin, its first orbiting solar power satellite. Measuring 400 meters in diameter, Merlin will operate in medium Earth orbit and beam 30 megawatts of microwave energy to Earth. At 80 tons, it will weigh 1/5 as much as the International Space Station, but cover 4 times its footprint. Looking further ahead, Space Solar plans Eagle, a 1.4 kilometer wide satellite in geostationary orbit, capable of beaming 600 megawatts of continuous solar power. Eagle requires 8 Starship launches to build. This massive platform represents the company's long-term goal of delivering gigawatt-scale energy from space. Phew, that's a large system. Let's look at something on a much smaller scale. Aetherflux, a Silicon Valley startup, plans to collect solar energy in space and beam it down to Earth. The company employs around 20 experts from NASA JPL, SpaceX, Lockheed Martin, Anduril, and the US Navy. The company believes that space solar power can revolutionize energy distribution, especially for areas where it's difficult or dangerous to deliver power currently. places like forward operating bases or disaster-stricken areas where the power's been knocked out. Long term, Aetherflux wants to deliver renewable and affordable energy, day and night, to power commercial and civilian use cases. Unlike Space Solar, for example, which is building massive kilometer-scale satellites in geostationary orbit, Aetherflux plans to deploy a constellation of smaller satellites in low Earth orbit. These satellites deliver modest power initially, using infrared lasers for higher efficiency, requiring only small ground receivers. Combining the improvement in technology with the rapidly increasing demand for energy, from electric vehicles to data and AI training centers, massive amounts of new power generation are needed. The company's compact 5 to 10 meter receivers enable flexible energy delivery, not only for the US Army, but also for the US Navy, allowing ships to receive power directly from orbit. Aetherflux has received its first satellite bus for Mission 1. Over the coming months, the team plans to integrate equipment onto the bus and verify all systems for a summer 2026 launch. The satellite, operating at a 550 km altitude in low Earth orbit, will transmit power using a 1 kilowatt infrared laser 30 seconds to 1 minute. Okay, let's look at a power beaming solution for the Moon. Volta Space, a Canadian space startup, plans to deliver power to any point on the Moon 24/7. The challenge for lunar rovers and scientific experiments is the extreme cold of the lunar night. Temperatures can drop to as low as minus 173 degrees Celsius for 14 days straight. Most lunar rovers are designed to function only during the lunar day, powered by sunlight, but they fail once the cold and darkness of the lunar night sets in. Volta Space aims to solve this by proposing to beam power directly to landers or rovers during the lunar night, ensuring they remain operational. Volta Space's lunar power satellite network is called LightGrid. This network uses a laser to beam power to assets on the lunar surface. The LightGrid network operates by capturing solar energy with lunar orbiting satellites, then using lasers to transmit the energy directly to lunar assets on the surface, ensuring continuous power even when the sun is below the horizon or for assets at the bottom of craters that are in permanent darkness. Volta plans to start its network with 3 small satellites in low lunar orbit, which can be scaled up by adding more satellites as the need for power increases. Operating from lunar orbit offers significant advantages. It provides global lunar coverage without the challenges of landing on the Moon, such as dealing with lunar dust and the shadows caused by the Moon's rotation around Earth. Volta Space has developed what they call LightPort. It's a receiver that converts the optical power beamed from the LightGrid satellites into electrical power needed by the lunar asset. The receiver is highly efficient, with a mass only 1/10 of even the smallest battery, capable of enduring a single lunar night. The receiver is capable of safely receiving hundreds of watts for multiple years. Its mass is less than 2 kilos, with a diameter of 30 centimeters. Other configurations can be made if requested, according to their website. In November 2024, iSpace US and Volta Space agreed to work together on providing power to future lunar landers. The aim is to integrate Volta's optical laser power technologies with iSpace's expertise in lunar transportation and infrastructure to create a survive-the-night solution, ensuring lunar assets can endure the extreme cold of the lunar night. Volta Space plans to demonstrate beaming 2 kilowatts of power over a distance of 100 kilometers in 2026. Following that, they aim to kickstart lunar operations in 2028, starting with the deployment of 3 satellites in low lunar orbit. Final thoughts. With power needs continuing to grow, not only on Earth, but in space and on the Moon's surface in the future, building off-world power grids makes sense. My take is that while these companies may be in competition, there is plenty of potential clients for all of these companies. Multiple power providers can exist and be profitable in a single country or region. The volume of space around Earth is vast, allowing many different space startups to offer power solutions to customers while maintaining profitability. In fact, competition will likely keep prices low. Is building a power grid in space a good idea? Do you think the right approach to generating more power in space is through constellations of power satellites beaming power to client satellites. And on the moon, is power beaming to lunar surface assets a good way to provide reliable power? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Watch the weekly live stream to see the images, clips and slides from this week's videos. It's a live Q&A on the week's space topics where I read out loud some of the best comments. The more people join, the more fun the live stream is. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.